Right now, on the user profile page, we are fetching every single post the user has ever posted. On our test application, it's not that big of a deal because we have a limited number of test posts. However, in a real-world application, depending on how active the user is on the forum, this could be hundreds or even thousands of posts. Loading in all these posts at one time is not practical, as it would cause ever-increasing performance issues. So, let's paginate them. First off, what is pagination? Pagination is when we fetch a list of data one page at a time. A page is just an arbitrary number of items. It could be 10 of them, 15 of them, or even 50 of them. The point is just that we're not loading all the data at once. Pagination could take the form of an infinite scroll, like on Giphy.com. Notice when I get to the bottom, it loads in some more items. That's a new page of GIFs. Or your pagination might take on a more traditional form and look like the pagination on this recipe website. Okay, so in order to paginate the data from the Cloud Firestore, we need to combine two Firestore methods, limit and start after. Limit takes a number indicating how many records should be returned, while start after takes a records document indicating at what point the page should begin. We'll also want to use an order by method so that we can paginate in a predictable order. Okay, let's try that out. I've opened up auth.js, and here we're in the fetch auth users post action. This is the action that fetches the user's post for the profile page. First, let's add order by and tell Firestore that we want the posts with the most recent posts first, and then have them descending in order over time. Then, let's say that we'll limit each page to 10 items. At this time, we'll just pretend we're only concerned about the very first page, so we won't implement the start after method yet. So, as the code is right now, when I open up the browser, what I'd expect to see is my latest 10 posts. Let's see if that's what we get. And no dice. We've got an error. This query requires an index. You can create it here. If you're coming from working with a relational database like SQL, this error might just throw you for a loop. The issue here is that in order to boost performance, Firestore does not crawl through the entire database item by item to get the results of a query. Instead, it searches through indexes for all queries. Much like the index of a book, which maps topics in a book to page numbers, a database index maps the items in a database to their locations in the database. For simpler, single-field queries, Firestore can generate these indexes automatically. That's why our query for the user's posts that just used where user ID equals auth user ID worked just fine. However, now we've added another field to the query, the published at for ordering. This means our query now requires what the Firestore calls a composite query, and these are not automatically generated for us. What is given to us is this nice handy link to have it generated. Let's click it. Now, all we have to do is click Create Index, and the Cloud Firestore will do all the hard work for us. Depending on the size of the database, this can take a bit of time, but when it's done, building will change to Enabled. Feel free to pause the video and come back when the Firestore is done creating the index. Now, with our index created, the user's profile page should be back again. Nice! And you'll notice that we only have the latest 10 posts. Before this lesson, I reseeded the database and manually added in 24 new posts, numbering them as I went. And 24 is in fact at the top, descending down to 15. Perfect. Now all we need is a way to tell the Firestore where to start subsequent pages, and a mechanism for switching between the different pages. Let's work on using the Start After method to tell Firestore where to start the page. Remember, Start After takes the Firestore document that you want the page of resources to start after. In other words, it wants the last post fetched in the current page. But what is that post? Well, let's create a computed property on the profile page in order to get that for us. First, if there are no posts at all, then the last post fetched is null. Otherwise, the last fetched post is the post at the index that is one less than the length of the user's .posts array. Cool. Now let's pass that to the fetch auth user posts action. And now we'll need to update the action to be able to accept that input. Now, we should update the query itself to use the provided Start After document. However, sometimes Start After is null, that is, for the first page. So, we only need to add the Start After method if Start After is not null. In order to do that, we'll temporarily store the query in a variable, and then call .get on the query to get the posts. In between, if Start After is not null, then we'll add it to the query. And query should be defined using let, not const, because we have to redefine it here. And one more thing we'll want to do here is actually get the Start After document as an actual Firestore document. We can do that by fetching the document afresh by its ID. Remember, the posts stored in our Vuex store have been transformed with the doc to resource function and are no longer Firestore documents. That's why this is necessary. Alright, now let's make it so that we can actually call a page other than the first page. Just so that we can quickly see if this works, I'll use a set timeout to just call page 2. Let's say 2 seconds after page 1. Whoops, we get an error. That's because I forgot to await the result of the query. Alright, now if I refresh the page, scroll quickly to the bottom, and wait for a second or two, you'll see the scroll bar jump, and our new posts are automatically added. Nice. Let's remove that timeout, as it was just for testing. In the next lesson, we'll use an intersection observer to create an infinite scroll effect so that each page is automatically added to the end of the list of posts when the user scrolls to the end. In the last lesson, we got the posts on the user's profile page paginated, but currently we're only supporting the first page. We need some kind of trigger to tell the browser to fetch subsequent pages. Well, on the user profile page, let's do an infinite scroll option like we saw used on Giphy.com. The first thing I want to do to create the infinite scroll is to create a component called app infinite scroll. I prefixed the component name with app so that this can be a reusable component throughout our application. And now I'll just paste in the code for this component, and we'll briefly examine what's going on with it together. Normally, for a component like this, I'd just install and import some existing library. But as of the time of this recording, I couldn't find a good infinite scroll component with adequate usage that worked with Vue 3. So, what's going on here? Well, the most important part happens in the mounted hook. Here, a JavaScript intersection observer is set up, and whenever the div in the template is within the visible page, the component emits a load event. If you want to know more about how intersection observers work, you can find a link to the MDN docs in the description. Also, much like an event listener, intersection observers should be cleaned up. So, in the unmounted hook, we tell the observer to stop observing. Finally, we watch a done prop, and whenever the parent component tells this component that it is done loading every page of resources, we can turn off the intersection observer. Also, in the style tag, even though our div in the component never actually displays anything because it has no content or given width or height, we do have a little bit of code to push its position in the DOM up a little higher than it would normally exist. The reason for this is so that we can start calling the next page of resources before we actually reach the end of the current page. This just makes for a little better user experience. Alright, that's the infinite scroll component. Let's now put it to use in the profile page. We want to put it just after the post list component. That way, whenever we reach the end of the list, the app infinite scroll component will intersect with the screen, thus firing the load event, at which time we'll dispatch our action again. And we can tell the infinite scroll component that we're done whenever the length of the user's posts array is equal to the posts count property on the user. Cool. Let's check it out in the browser. When we scroll now, you'll see as we near the end of the first page of posts, the page scroll bar jumps a little, and then we just keep on scrolling into the second page. Pretty sweet. In no time flat, we've got infinite scroll up and working. Let's do one more thing in the profile page component, just to clean things up a bit. Since we're dispatching the fetch auth user's post action more than once with the exact same options, and the action name and the parameter code is a bit verbose, let's make that into a single method and then call the method in the created hook and on the app infinite scroll component load event. And in the created hook, let's make sure to await the fetch user posts action to finish before telling our application that all the data is ready. Also, for this to work, we'll need to return the promise returned by the action dispatch. Alright, I think that should do it. Cool, everything still works. In the next lesson, we'll see how to implement a more traditional pagination on the Threads page with pagination buttons. In the last lesson, we used an infinite scroll feature to paginate the posts on the user profile page. In this lesson, let's take an alternative pagination approach for the Threads page so that you'll be familiar with implementing both, depending on the needs of other applications you might be developing. For the Threads page, we'll use the more traditional pagination buttons as pictured here. In order to do this quickly, we'll use an existing pagination component library. If such libraries exist, are compatible with your project, are stable, and accomplish what you need, it's always a good idea to take advantage of that. There's no reason to reinvent the wheel. So, the library that I'm going to use is called Vue3 Pagination by Hinge. It's at a stable version. It's been worked on in the recent past, so I know it's not abandoned. And even though it's not that widely adopted of a solution, it does exactly what we need it to do. And it's the best Vue 3 compatible solution I could find that wasn't wrapped up in an entire library of components like Quasar or Vuetify. So, the first thing we need to do is install it. I'll copy this line here to do so. And I'll add the -- save flag to the end so that it saves to our package.json file. Once it's installed, I'll create a file in the plugins directory where we can register the component via a plugin. First, we'll need to import it and its style sheet. Then, we'll export a function that receives the application instance and calls .component on it to register the vpagination component. Then, we'll put the plugin to use in main.js. It's worth noting that making this into a plugin isn't strictly necessary. We could just import the component directly into the project where we needed it, just like it shows in the library's documentation. Or we could have imported it directly into the main.js file and called .component on it there. However, I like to try and keep third-party libraries organized into a single directory, that is, the plugins directory, as much as possible. So that's exactly what we did here. Looking in the docs now, we can see an example of how we should use the component. First, it looks like it takes a page variable that determines which page should be highlighted as the active page, and that will be updated to a different page value whenever the user clicks a different page number button. It also takes a pages property that, I assume, means the total number of pages that we have. Next, it takes a range size prop. I'm not sure exactly what that one does. We can dive into it later if we need it. And it takes an active color prop. This will be useful for styling it to fit better with our application's style. Lastly, it emits an update model value event. Listening to this event would be the same thing as watching the page value and executing some logic whenever it changes. Cool. Let's just copy the example as a starting place and use it on the forum page. We want the pagination to show up underneath the list of threads, so we'll put it here. Now we can start working on giving it the props it needs. Let's create a page data property to keep up with what page we're currently on. It should default to 1. Next, we need to know how many total pages of threads exist for the form on this page. This is one downside to the pagination button approach. It adds a little bit more complexity because it has to know how many buttons to show. The infinite scroll approach doesn't care how many pages there are. It just keeps loading them in until there are no more. However, it's not that big of a deal, as you'll soon see. In order to determine the total number of pages, we need to know just two things. We need to know how many threads exist for the form and how many threads we want each page to contain. Since we use 10 posts per page on the user profile page, let's do the same here. Now, in order to get how many threads exist on the forum, we can read the length of the threads property on this.forum. Remember, forum.threads is an array of thread IDs that we are storing in the Cloud Firestore to keep up with what threads belong to what forum. With that, we can do a little math in a computed property to get the total number of pages. Dividing the thread count by the number of threads per page gives us the number of pages we need. Then, running math.ceil, which is short for math.ceiling, on the result rounds the number up to the next whole number. This makes it so that, for example, if we had 12 threads and wanted 10 threads per page, the result of the division problem would be 1.2. We can't really have 1.2 pages, rather, we want 2 pages with the second page just not being completely full. So the math.ceil does that roundup for us, making 1.2 into 2 pages. Lastly, we'll just want to return the result. And I misspelled math. Let's also create a little safety net here to make sure we never divide by 0. Cool. Now we have the total pages to pass to the pagination component. I'm just going to remove range size because I don't think we're going to need it. For active color, I'll provide a green color from our application. Alright, let's see where that's got us in the browser. Nice, that's some good progress. Let's add a few more styles just to pretty things up a bit. Okay, I think that's a little better. Now we need to handle the real work. What do we do when the page changes? Let's create an action to handle that. In our Threads Vuex module, I'll create a Fetch Threads by Page action. And it's going to take in the thread IDs on the forum, the page number, and how many threads should be on each page. We can just default it to 10. You'll notice this looks a little different than the action we had for the user's post. That's because we've stored the data a little differently, and I want to show you a different approach. Unlike with the user posts, each forum has a key called threads that stores all the IDs of the corresponding threads. That's what the IDs parameter corresponds to here. So, what we want to do is break all those IDs into separate pages, and then only dispatch fetch threads for that page of IDs. Thankfully, Lodash has a super handy function that can do that for us. And since we've already installed it in an earlier lesson, we can just import the function and use it. The name of the function is chunk. Notice how we're specifying just the chunk function here, so that we only import one function and not the whole Lodash library. Let's take a look at the example of chunk in the docs so that you get a better understanding of how it works. We see here that chunk takes an array for its first argument, and then a number that specifies how many items we want each chunk, or page, to contain. So, an array of A, B, C, D becomes an array of two arrays, each containing 2 items each, AB in the first array and CD in the second. Also, if the number of items in the array can't be divided evenly by the provided number, then the last element in the array contains the leftovers. This is perfect. That's exactly how pagination works. So, let's put it to use. We'll call chunk on all the forum IDs that come into our action. And we'll pass it the per page as the number of items we want per chunk. Then we'll get the proper chunk of IDs by targeting the index of the chunk corresponding to the requested page. We have to do the -1 here because arrays are 0 indexed, but our pages are not. Our pages start at 1. The array starts at 0. Finally, we'll dispatch the fetch threads action we've already been using, now just with the limited set of IDs. Over in forum.view, we can replace the fetch threads with our new fetch threads by page action. Also, passing it the forum IDs, the current page, and the threads per page. And we'll need to remap the action accordingly. If we take a look in the browser now, we'll see that the first 10 threads are showing, but all the others are still showing rows, even though their data hasn't been loaded. The reason for this is because our threads computed property is using all the thread IDs that exist on the forum to determine the value of the threads instead of threads being determined by the threads in the store that have this forum's ID. Let's change it to do the latter. We'll look through all the threads in the store, filter for the ones that match this forum's ID, and for our map function, we're no longer working with just an ID anymore, but the whole thread object. So here we would need thread.id. Cool. Now let's handle the page change. The vPagination docs show calling a method on the update model value event. I prefer to just watch the page data property instead. It's essentially the same thing, but watching the page data property means that even if it changes for some reason other than the pagination component updating it, the handler will still fire. And what we want to do when the page changes is we want to dispatch the fetch threads by page action again. We'll also want to dispatch the fetch users action again, as the new threads might be by users that aren't loaded in yet. Don't worry if this looks a little repetitive. It is, and we'll fix that in the next lesson. Let's see what this looks like now. When we click each new page button, the new threads get appended to the list. Let's clear out the existing threads from the store before getting the new pages worth of threads. We'll create a clear threads mutation. And then we'll commit it first thing in our fetch threads by page action. Great! Our pagination is working. It's worth noting that some of the differences in implementation in this lesson versus the infinite scroll lesson were not due to the different pagination approaches, but rather to the difference in the way that data was stored for each. Besides storing the thread IDs on the forum itself, we're also storing the forum ID on the thread. So, if you'd prefer to use a Firestore query to do pagination on the threads page, like we did on the profile page, instead of doing the chunk stuff with Lodash, you certainly could, and it would still work with the pagination buttons. In the next lesson, we'll make it so that the page can come from the query string in the URL. That way, you can share a link directly to a specific page. Our pagination feature's working great. If we wanted to share the link for the second page to a friend though, how would we do that? Well, right now we can't. But if we had the pagination info in the URL, like $page equals 2, then we could. Let's do that in this lesson. View Router actually makes this task quite simple. Where we've hard-coded our page to start out as 1, let's instead look for the page query in the URL first. And then, if it's not available, set it to 1. Also, since everything that comes from the query string is, well, a string, let's use parseInt to turn the page number into a number. This will ensure the value is a predictable type and plays well with the vPagination component. Now, when we watch the page data property, instead of fetching the data again, we'll just navigate to the new route with the query variable page changed. And since the route has changed, the page component will be destroyed and re-rendered. So the created hook will rerun, taking care of the data fetching automatically. Alright, the first page loads correctly. Clicking on page 2 correctly updates the URL. However, we get stuck with this loader spinning forever. Let's check app.view to make sure it's destroying the page correctly on route change. I see. The key is set to route.path. And since we haven't actually changed the path at all, rather just the query string. The component is not being destroyed and re-rendered. Therefore, the created hook is not firing again. Let's update that key to include the query string as well. I've used json.stringify here so that we can observe the entire query at once. Great, everything's working as we'd expect it to. And if we want to share a particular page of threads with someone, now we can do it.